I'm just going to solve for this one in molarity, but I just want to make sure that you remember, because sometimes at this point, because we've had so much one-to-one, people forget how to deal with there being more than one ion. So I'm going to jump over here to magnesium. There we go, magnesium hydroxide. The KSP for this is, I've got at the top 8.9 times 10 to the minus 12th. So just don't forget with that 2 there, when I break that into an ion, that's going to make 2 OH minuses and an Mg2+. If you like the 2+ first, it's totally fine. You can put it that way. I just was trying to emphasize how many OHs that there were. ICE, nothing matters here. 0, 0. Don't forget that that's actually 2x. That's 2x. That's x. That's x. Now the KSP for this, and let me make this a little smaller so I can write it off to the side. Mg plus 2 times OH squared equals 8.9 times 10 to the minus 12th. So this is x times, be very careful right here, that's 2x squared. Again, all the 2's are there. It's because of that one right there. And again, because of there being a 2, that's squared. And make sure when you do the math, you actually do square both the 2 and the x. The square applies to everything inside that parentheses. So that would be x times 4x squared. So then you do the next round of math. This is kind of like saying x to the first. So that becomes 4x cubed is 8.9 times 10 to the minus 12th. Divide both of them by 4 and then take the third root of both of them, and that'll give me x. I'm going to bring this over here. 8.9 e to the negative 12th divided by 4. And then I like to, on my calculator, I just like to do raised to the, 1/3. So that tells me it's 1.31 times 10 to the negative 4. That's the molar solubility of the whole thing, of MgOH2. And you can set up on those factor labels if you're not sure about that, just to make sure that that's what you get. You know, that's how, even though X is Mg, you can set up a factor label and convert between Mg and MgOH2, just so that you see that it's all 1-to-1 and you're going to get the same molar solubility.